That was our intro music because that machine was making very complex music. But if you look at it, it's just marbles and little bits of wood and tiny little simple pieces that some clever people from Sweden with a lot of hard work put together to make a machine. And I encourage you to go to YouTube and find the making of the marble machine video. If somebody could Google it and drop that link in chat that you can watch later. That machine is all very simple pieces, and they explain how it works. And that is the sentiment that I'd like you to approach this class with. There is nothing in that machine that we cannot understand, just a bunch of simple pieces put together. It's like made out of Legos and wood and marbles and the bass guitar, right? In this class, we're not going to do anything complicated in this class. We're just going to look at simple pieces, basic algebra stuff that you learned in the 7th grade, and put those simple pieces together along with common sense and hard work to understand the world around us. Yes, the Google people, not the Marble Machine X, we're still waiting on them to finish that one. So, I'm catching up on chat here. Have we already been rickrolled? Okay, it is the second day of Physics 211 and we have already been rickrolled. I love you guys. So, thank you. There was one last time too, good. I'm starting here with a quote from Galileo. So, our very first thing we would like to understand is the simplest possible phenomenon we have in motion, which is falling objects. It's kind of maybe the earliest question scientists asked before the word science was even written down. Why, when I take my keys and I drop them, why do they fall? How do they fall? That's the question we're going to look at today. Galileo, in the 1600s, wrote, "My purpose is to set forth a very new science dealing with a very ancient subjects. There is in nature perhaps nothing older than motion, concerning which the books written by philosophers are neither few nor small. Nevertheless, I have discovered by experiment some properties of it which are worth knowing and which have not hitherto been either observed or demonstrated. So far as I know, no one has yet pointed out that the distances traversed during equal intervals of time by a body falling from rest stand to one another in the same ratio as the odd numbers beginning with unity. Unity meaning one." Written by Galileo in the book Dialogues and Mathematical Demonstrations Concerning Two New Sciences in 1638. I need to either lose some weight or get me some more room to stand. What Galileo meant by this is if you take a thing and drop it from the top of the Leaning Tower of Pisa, which he is reputed to have done, then it falls in this pattern. In the first little chunk of time, it falls one amount of distance, but in the next little chunk of time, it falls 3 times as far, then 5 times as far, then 7 times as far, then 9 times as far. So our goal today is to understand that thing. Lopielski in Twitch chat, you say you're transferring to Syracuse. If you're not already a Syracuse University student and you've wandered into our Twitch stream, talk to me after class. So Funky Joe, we will talk about the idea of terminal velocity later in the semester. Yes, Yuan, Shane, people talking about the slides, I will address that in like just a moment, and I want your input. Before we do physics, though, my little slide clicky thing, we need to do some announcements. So for those who may have registered late or missed class earlier, this is our intro slide. This is the class you're in case anybody's in the wrong class. The title of our class. Anybody recognize this crowbar? Here are the leaders of the teaching staff. I'm the professor, Walter Freeman. Mario Olivares is our lead TA, and Adam Ali is our lead coach. We have many, many other coaches and TAs. That is not the Nike swoosh. Yes, hostile hamster TH. This is, in fact, Gordon Freeman's crowbar from Half-Life. We might encounter that later. I got Gordon Freeman jokes like my entire first year here, so it kind of became a meme. All of the information you will need for this the course is posted on the public internet here. It will also be on Blackboard, but just for ease of access, stuff for our course lives there. So what are we going to do today? First, we're going to do all the non-physics stuff. That was the welcome. I'm going to remind you of some things. We're going to talk about recitation yesterday and going forward. I have a few things to announce, and then I want to give you a few words on how to succeed in this class. Then we're going to do some physics. We need to figure out how to describe motion, to come up with a language to describe motion with. This is going to lead us to words like position, velocity, and acceleration. And we're going to relate them conceptually, graphically, and algebraically. Lepielski, this is not intro to music theory, although if you want to discuss music theory, we can certainly do that. I was a music minor and studied composition and conducting when I was an undergrad, so if you need help with your music theory homework, come to my office hours and we can talk about music theory. But this is not music theory. So, recitation. Recitation is the most, so actually let me back up. I see people like memeing a bunch of stuff in Twitch chat, but also there's a question about turning in homework. I will have a block of time for questions about those sorts of logistical things in just a minute. So please hold those questions for just a sec. Nator, though, in Twitch chat has kind of said what we're going to say. Can you join those ideas through calculus using the idea of a derivative? And in fact, that is precisely what we will do. Fix that problem later. So, recitation is the important part of this class. If you want to skip lecture, go ahead, you're not going to hurt my feelings. But you've got to come to recitation, because that is where you will practice the skills that you will need in physics. So tell me, how did recitation go yesterday? Missing, no, I see your comments, I see all the calculus comments. I'm going to come back to those in just a bit. But before we get to that, how did recitation go before? Good, Pog, great, to be honest. The silence within your group was amazing. Tell the people in your group they need to talk to you. Akweshi says it was nice working with others. Who are the people you will learn from in this class? Who are the best teachers you have in your class? Not me. I am the worst teacher you will have in this class, because there's one of me and a lot of you. Come to my office hours, I'll help you as much as I can, but there's a lot of you. Each other, yes, Uma, Rebecca. The people here who will help you understand things better than anyone else are each other. You are your own best allies. The other people, of course, you have coaches, you have TAs in your recitation, and you have me. But this is not an individual class. This is a we're all in this together class. You're all going to be doing the same homework, right? So work with each other. I see people in Twitch chat talking about how some folks in their groups were talkative and some other folks in their groups were not so talkative. If there are people that you work better with or don't work as well with, you may change your groups from time to time to be with folks, like I saw the three of you who are behind the camera. We're working fantastically together yesterday. So keep in groups that work well for you. Olive Moose says, are we always going to work with the same group in recitation? I encourage you to find a group you like and stick with them. So the three of you work well fantastically. Y'all want to be friends all semester and go through physics together? Great. In Zoom chat, Lucas says, we could have used more overview and explanation. Felt like we skipped over a lot. Ask those questions. If there are things that you skipped over that you'd like to talk about, ask them here. Ask them in your recitation. The exercises that you have for recitation are not a test. They are not the end of you learning things. They're the beginning of you learning things. So if you've got questions about things in recitation, use the little raise hand thing in Blackboard Collaborate. Teaching staff will come by and chat with you. My man Howie, I don't have a degree in math. I was a math minor, but I don't have a degree. It's up top. It's Bridget was saying has a math degree. So the so this was people were talking in Twitch chat. I should scroll up. What we did yesterday, right, was looking at how things like minutes and seconds and hours and meters and kilograms can be manipulated just like algebra ideas. Mira said, Mira had to skip recitation to go to the doctor. I hope you are okay, Mira. The most important thing for everyone in this class is our health and well-being. So Akwashi says, will we have a mini lecture before you do exercise and recitation? Typically, it will be what we do here. So Akwashi, usually what will happen is what you do in recitation is practicing what you did here the day before. Now we couldn't do that before because Tuesday was all day talking about how we'll do online class. But Akwashi, yes, like what we do today is what you will practice tomorrow. Let me scroll up in Zoom chat to see if I missed stuff. Can we review some stuff related to homework? Yes. Next Tuesday and next Thursday, there will be an opportunity here in class for you to ask questions about the homework, and we'll talk about it on the board. Mira, if you missed recitation, the materials are online. We have a formal thing for you, what to do to get credit for recitation if you miss. Don't worry about that for yesterday, because that was the first one, right? But Adam or Lyra, if you could grab that section of the syllabus and drop the anchor link right into Zoom chat for Mira. Thank you. Queen Fallen Viper in Twitch chat says, Rip, we gotta wait until next week for homework help. I have office hours tomorrow morning. So tomorrow morning or after class, you can ask me homework stuff right away. But here, we're going to do that next week. We want people to have some time to take a look at it. Other questions? People making chocolate milk. I want some chocolate milk. I made some last night with ginger in it, and it's fantastic.
I have a question.
You have a question?
As it relates to the quiz at the end of recitation, is it that we have the quiz at the end of? How does it work?
So she asks, how does the recitation evaluation work? It will be different every time. Sometimes it will be like that. On Friday, we'll just come talk to you during recitation. So someone will stop by your group and have like a 3-minute conversation with your group, and based on that conversation, they will give you credit. So it'll be different from recitation to recitation. There are a couple of options in the syllabus. Either someone will come talk to you. Next Friday, the recitation after your homework is due, the recitation question will be a thing having to do with the homework, where your group can kind of discuss what something meant in the homework, and based on that, you'll get credit for recitation. So we're going to switch it up from time to time. Luke, you can get a bad grade on the quiz if you don't know what's going on. So Luke, you can ask for help. So the quiz questions and recitation, you can ask each other. You can ask your recitation TA. We want to help you understand stuff, but ultimately if your answer to what is 2 + 2 is squirrel, then you won't get credit. Christopher Vinn asks about answer keys for recitation. Yes, you can get an answer key. The answer key is the 36 people that are helping to teach this class. So if you've got a question about recitation, any of the recitation materials, the best way for you to get your questions answered is to ask them. Pop into the Discord, send me an email, send your instructors an email, come to my office hours. We'll get you an answer that's not just a dead PDF. We'll get you a living answer and talk you through whatever the thing is that you're unsure about. Armani, where do you turn in the recitation materials? You don't. You keep them. They're for you to learn from, not as an exam. Dinara, will you receive email? Yes, sometimes I announce things to the whole class. I'll broadcast them to everyone. So Dinara asks about in-person recitation. So I guess I will click through to my next announcement slide. We're working on getting more capacity for in-person recitations. We hope to be able to accommodate everyone who wants to go to recitation in person starting next week. We have another room. I will be sending out another survey for you this weekend asking about your preferences. Once I know that, once I understand those preferences, I will contact people who want to do in-person recitations. Shogunite, you can't see your recitation evaluation on Blackboard. Yes, we'll make them available eventually. We have to do some back-end work on our end to merge all of the sections because Blackboard is a steaming pile of garbage. Blue Sock says kappa, 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 kappa. Where do you find the class Discord link? It's on the class website. Somebody already dropped it. Kate Mel says, in terms of assignments, will it normally be quizzes after recitation and homework due Friday? Yeah, something like that, although the homework will really be like every week and a half. We'll bounce back and forth. We have a chocolate milk versus strawberry milk debate. Maya Cohen asks a really good question. Do I go over the recitation worksheet answers in lecture? If you ask. So during every class, I will have a period where I say, please ask me questions. You can ask about the homework, you can ask about the recitation, you can ask about anything. You can ask me how a nuclear bomb works, if you want to. I'll probably talk about that, the next class. Ask me anything you like, physics related, and we'll talk about that. Will you be deducted points if you misspell the TA's name? No, you won't. But you should, by the end of the semester, pretty quickly, know how to spell their name. Okay, other questions. Transfer to Temple, we have Canvas. How does it decrypt? So the FBI knows exactly where I am. I'm in the basement of the physics building. Can you purchase uranium through me? No. All right, dunes. So those sorts of memes are not cool. All right. So greetings from Switzerland. Okay. The last thing that I wanted to do in the non-physics part of this class is to give you some advice for success. Notice that there are no words behind me because the important thing here is the sentiment. This is not a class where you go to lecture, you take detailed notes, you go home, you sit in a cave, you do all your homework, you spend hours doing your homework, you write everything out, and you turn it in. This is not a class where we expect you to do any of your work on your own. This is a class where we are together learning skills. So I want you to think about a skilled thing you do. Maybe you play sports. If you do, think about how you learned to shoot free throws in basketball or to throw a football, or to do dance or gymnastics. Maybe you play a musical instrument. Think about how you learned to play the piano or the clarinet or learn to sing. Maybe you know martial arts. Think about how you learned to throw people in judo, how to fall in aikido without getting hurt, how to grapple in jiu-jitsu. Think about how you learned those things. Physics is like that. You didn't learn to play the clarinet by listening to a lecture on playing clarinet. You didn't learn to throw people in judo by watching someone else in the dojo do that. You didn't learn to shoot free throws by sitting on the sidelines and watching your coach shoot free throws. You learned those things by doing them. And as you did them with other people, and you had a guide with you, a coach or a piano teacher, give you advice on what you were doing. So physics is like that. Madeline says, physics is not a spectator sport. Chunky Funky Monkey, I played basketball in the 7th grade and I was terrible at it. You don't want to see me play basketball. So if you are in this class working on your stuff, keep those analogies in mind. Work with other people. When you're doing the homework, remember, you're not supposed to do it on your own. You're supposed to come ask us questions. I will be sending you more information about how you can work with us, how you can work with me, how you can work with your teaching staff when you're doing your homework. Take advantage of those resources. You are not supposed to sit alone in your dorm room and do your homework. Yes, I know we've got a pandemic going on. Yes, I know not alone means you've got headphones on and a webcam and an iPad and all of these things. But to the extent that we can, work with everybody else. Everybody's memeing about basketball. I am terrible at basketball. Queen Fallen Viper in Twitch chat says, that makes sense. I took a look at the homework and I was in the try not to cry a lot meme. So here's the deal with the homework. The thing you might say about the homework is, I don't know how to do this yet. Remember, this is a class where you're supposed to learn stuff. You are going to rapidly gain skills in physics by doing physics, and by the end of next week, you'll know how to do all of those questions. If you're not sure, ask us, right? Work with folks. So another thing about this class, what grade do you have to get an A- in this class? What percentage do you have to get an A-? 80. An 80 or above is an A, a 65 or above is a B, a 55 or above is a C, and a 50 or above is a D in this class. That's true in a lot of science classes. We're going to ask you to do challenging things, but we know that. And if you can do 80% of challenging things, you're doing pretty awesome. Or as my PhD advisor put it, everybody messes up 10% of the math, and then if you mess up 10% of the physics, you're still an A student. So Twitch chat is PogChamping all over the place. The exams are going to be hard, but if you do 80% of those hard things, you get an A. Okay. Are there any other questions that people have, either about physics or about the process of our class before we start doing physics? And I'm just going to grab them as fast as we can. My man Howie, the average grade last semester was a little bit, in a normal semester, the average grade is usually a B in this class. It ranges from B- to B+. The average grade last spring was a little bit weird because we had an issue with people using Chegg on the final exam. Don't do that. Other questions. Dinara says, Alice, you're amazing.
You're welcome.
My girlfriend just popped in and gave me an apple and peanut butter cups and a fruit bar, and she's the best person ever. Dinara asks, can we type the answers or handwrite them? You may do either. Handwriting is kind of what we prefer. Don't type unless you know LaTeX. You can write on a tablet with a stylus, but most people will submit their work by using a good old pencil and a good old piece of paper and cam scanner on their iPhones. If you need any help doing that, ask me. When is the homework due? It's when we tell you it will be due. It'll be due before recitation, either Wednesday or Friday. Jeremy, do you have to take notes? Let me talk about that after this. We have people talking about how you blow up stuff with poop. Siddiqui, can we talk about the homework? So, Siddiqui, what I'd like you to do for the homework is, after tomorrow's recitation, take a whack at it. And then next week, Siddiqui, come on Tuesday with specific questions. If you can say, can you give me a hint on number 3? I have this thing I don't understand about number 4, and we'll talk about those specific questions. But the question of how we answer the homework questions a little bit better, that's what we're about to do when we do the physics. How many questions are on the final exam? I don't know yet. What will we learn that's mostly on the exam? All of those things will become clear as we go. Like, once we get to the exams, I'll tell you very, very precisely what it is. Siddiqui, just as a note, if I mispronounce your name, like you say I've pronounced your name correctly, but anybody, if I mispronounce your name, just correct me. I want to pronounce your names correctly, so if I mess something up, it's because I'm dumb. Help me get it right. The other thing is, just as an FYI, I cannot hear as well as some people. I have an ear that doesn't work. So if I'm talking to you and I can't understand you, especially since often we'll be wearing masks, if I'm talking to you and I can't understand you, it's my fault because this ear doesn't really work. So I may just ask you, could you repeat yourself? I see Adam answering questions in chat. Okay, we had a question about lecture notes. So let me talk about how that's going to go. And I want your feedback. I want to do this in a way that works the best for you. So what do we have today? I've got a bunch of blank slides, and I'm going to write on the chalkboard behind us. But then, after that, I have a bunch of slides that are copies of what we did last year. So for people who want a set of notes, you can go to the end of the PDF and click through these, and this is kind of what we're going to do on the chalkboard. Now, I may change that up from time to time, and I'd like your input on what works best for you. I'd like to provide you notes, but I'd also like to, mostly what we do, to do in a living way on the chalkboard rather than in a dead way on PDFs. So please give me feedback on what will be the most useful for you, and I will try to adapt to what you're doing. You know, I may like handwrite notes, notes that I have for myself, and then post those. So let me know what I should do. Said Ferret Boy, what should you do if you're dead on the inside? I think Evanescence wrote a song about that was popular when I was in school. Missing No, could you use the bathroom? I hope so. Could somebody give Freddie Snuggs the link? Abwife, could it be a combination of both? Sure, I will do stuff. Yulun likes traditional chalkboard stuff. So let's do some traditional chalkboard stuff. So as you probably know, there's a chalkboard behind my green screen. Pardon me, let all of this go. Come on. Okay. So here's our chalkboard. And I'm now going to go monkey with the camera so people can see stuff better. Give me just a second. Whoop. There we go. Now I need to do that. All right. Okay. I have one more thing I want to click, which is that button. Okay. So, where we begin is trying to figure out how to describe motion. So, we can describe moving things in, I gotta test one thing before I do that. Yes, okay. We can describe motion in a lot of ways. Words, graphs, symbols, and numbers. So, the example I used, free fall, of me taking my keys and dropping them, well, I know they move slowly at the start and move faster and faster as they fall. That's a description in words. We'd like to make that precise. And you can make that precise with a graph. So one thing I might do would be to make a graph of height, or maybe I would label it position on the horizontal, whoop, wrong axis. We'll put time on this axis and position on the vertical axis. And if I drop something, what would this graph look like? Missing No asks if I am using Hagoromo chalk. Whoop, the green one doesn't show up because I still have my green screen mathematics on. Yes, I'm using Hagoromo chalk. Yes, it would be a parabola. It's going to be a concave down parabola because our thing starts up here wherever I have dropped it from, and it curves down. So this might be a description of free fall. Me dropping my keys. And as people have typed in Twitch chat, I can also describe this as a mathematical function. And people are saying it's a parabola and writing things with squareds in it. Jenna said exponential. It's not an exponential function, it's a quadratic function. Often we use exponential for anything that's not linear, but it's not e to the x, it's actually t squared. So this is a depiction, a graphical one, but I could also make a description that's symbolic. I could write, for instance, get my colors straight, I could say position as a function of time. Whoop. Is, well, how high did it start? This is going to be some starting height h, and there's some mathematical function that describes this curve. Now, we will find out later in our class, we don't know this yet, but we will find out later that the function that makes is h minus 1/2 times the acceleration times the time squared. We don't know why yet, but we're going to figure out why soon. So what I'm getting at here is we've got two different ways to describe things. A here is an acceleration. We don't know what that is yet. And using descriptions like this, we can figure out a whole lot of stuff. This equation right here is called an equation of motion. All that does is gives an object's position as a function of time. So our goal then is often going to be to figure out equations of motion. And I see that those words have kind of gone weird. This is because my computer is still green screening stuff. So we'll turn that off. Give me one sec. Green screen math is happening when it shouldn't, and it's messing stuff up. What have I done? What have I done? There we go. Now we're good. Yeah, green screen chalk, it looks funny because green screen. So yes, this equation is the symbolic way of representing how something moves. And you can figure out a lot of stuff using this equation of motion. So let's ask a question. How would I, using this picture, suppose this is the ground, how would I, using this picture, figure out the time at which this object struck the ground? What would I do? So Christopher has told me using this. So, I probably should write smaller so I have more room. I'm new at this. I usually teach this class with slides. I've never been able to use a blackboard before because I've always been in a giant auditorium. So bear with me as I get better at doing this in the chalkboard. So we're gonna erase the picture for now. Come back to it. So if I want to ask, when does the object hit the ground? Well, this question is the same as asking at what time does x equal 0? So one of the skills that we're going to need to practice, yes, x of t, because x is a function of t, thank you. One of the skills we will need to practice is figuring out how to go from a question like this, when does the thing hit the ground, to a question that I can answer algebraically. This is a critical skill that we often don't really think about that much. Here's a question in plain old words. But this question tells me how to do the algebra. It tells me what I need to do is to take my equation of motion and then set this thing equal to 0, yeah, and solve for the time where this equals 0. Educational purposes refers to this as decoding word problems in Twitch chat. I would translate this as translating word problems, of taking a problem asked in language and writing that problem in a form that allows you to translate to algebra. So this is the first thing I wanted to talk about describing motion. But we now have another piece of description we need to learn to do. I'm going to check the time here by pulling out my cell phone to see how much time we have left. We're good. So we know, we kind of talked last time about how the central idea of this class is F equals ma, Newton's second law of motion. So Newton's second law, and I'm writing this in colors for a reason, tells us that forces on objects make objects accelerate, which means I have to somehow relate the idea of acceleration back to the equation of motion. The title went away. I clicked something I shouldn't have. So we'll get that back. Boop, boop. There we go. So to do this, we need to know what acceleration is. So tell me kind of in casual terms, lay terms, what does it mean if something is accelerating?
It's going faster and lower.
Is the rate at which the velocity changes?
Yeah, its velocity is changing, its speed is changing. The second derivative of position we were talking about, to speed up. So what you all have just told me then is that acceleration is related to velocity by the idea of a rate of change. So this way. Acceleration is the rate of change of velocity. And likewise, velocity is the rate of change of position.
Right.
So what that means,
Acceleration is the second derivative.
ah, so I just heard you say something about a second derivative.
Right.
Yes. So for those who have taken calculus, and all of you, some of you have taken calculus already, some of you will take calculus. White chalk. A rate of change is called a derivative. So, for instance, if I have an object whose position versus time graph looks like this, tell me about its velocity.
It's increasing at a constant time.
So you say the velocity is increasing?
Wait, is the
Uh,
position, right?
Yeah, this is position.
Wait, oh.
It's going at a constant velocity.
It's going at a constant velocity, yes. Right. People have said velocity is the slope. So let's add this to our list of terms. Yes. So here, this motion is constant velocity. Missing no says the velocity graph would be a constant horizontal line. So,
So like if velocity is constant, acceleration is zero.
and if velocity is constant, acceleration is zero, the other folks said. Right. Because acceleration is the rate of change of velocity. So if the velocity is not changing, the acceleration is zero, because its rate of change would be zero. So we now understand how, if I know position, I can find velocity. If I know velocity, I can find acceleration. I'm actually going to draw the arrows the other way. You'll see why in a minute. So if I know position, I can take a derivative, or I can inquire about the rate of change of position to find velocity. If I know velocity, I can ask what is the derivative of that to find acceleration. And as people are saying in Twitch chat, if I keep going, the next one after acceleration is called jerk. And then the next three are called snap, crackle, and pop. Somebody was being silly. But we're not going to use those here. So we now have some language to relate these ideas. If I know position, I can find acceleration. So take derivatives or ask about rates of change. But Newton's second law tells me acceleration, right? F equals ma tells me what the acceleration is. I've got to go backwards. How do I do that?
Integrate.
Integrate.
I integrate. So, for those of you who know what integrals are, who know calculus, you can kind of do that symbolically, right? But not everyone has studied calculus in this class. Not everyone has studied integrals. So what I want to do is I want to, in a graphical way, motivate the idea of an integral. So the subtitle of this class is All the Calculus You Need to Know. Lucas says, if force equals mass times acceleration, and something is moving at a constant velocity, that would mean the acceleration is 0. Would that mean that the force of an object moving at a constant velocity is also 0? Yes, exactly, Lucas. If you know something is moving at a constant velocity, you know that if you take all the forces acting on it and you add them up, you get 0. Oatmeal SU says, this is the class where we know what the plus C is. Yes, that is coming in just a minute. Oh, I just got a low battery warning for a computer that is doing something important for me. I have to plug something in or Zoom is going to explode. So, oh no. I don't have the charger that I need. So what we're going to do, give me a second. I got to think of a solution to a problem I have. I didn't bring the charger that I needed with me. How bad or off are we?
What charger is it?
It is a USB-C charger like a MacBook would use. Any of y'all got one?
Yeah.
Oh, you are my heroes. You are my absolute heroes. If you could loan me that charger, that would be utterly amazing. Thank you so, so much. My cell phone uses this same charger and I left it at home. I've got too many computers and too much electronics.
Imagine you saw these people.
You are my hero. All right. I'm just confirming that we are getting power. Yes, we are. This is a Dell laptop and she handed me a Mac charger, so I just wanted to make sure it was compatible. We are good. So Lucas says, so a car moving at a constant rate of 60 miles an hour has no newtons of force behind it. And Krutartha says, it's the sum of all the forces. Yes, a car driving at a constant rate has air resistance pushing backwards on it, traction pushing forwards on it, and they add up to 0, exactly as Krutartha says. So, what I'd like to do now is we're going to do a series of questions. I need to click a few things to get something back here after yeah, there we go. So here we're going to do kind of a series of exercises to motivate the idea of an integral. So the first thing I want to do we're going to make one of these graphs, but we're actually going to put numbers on it. Oops, I don't mean position here, I mean velocity. In meters per second. And I'm going to put tick marks on my graph. We're going to do this. Let's label them 10, 20, 30, 40. So we have objects going pretty quickly. And for time, we'll do 1, 2, 3, 4, 5. So suppose I've got an object here that has traveled at 20 meters per second for 4 seconds. How far does it go?
Could you repeat that?
Sure. So my object, its velocity is a constant of 20 meters per second, and it has moved at that speed for 4 seconds.
80?
80 meters, how'd you get that?
Multiplying them?
You multiplied that. Okay? Now I'm going to change the function. So, $80 meters. Let's change it now. What if now we do this? Now how far has the object traveled?
That is 2 times
50?
plus
People are doing math, right? So
60.
60.
60.
60 meters, yeah, a bunch of people were saying 60. So how did you get that?
It's
Well,
basic-
say again?
because we're finding the area under the curve, so you.
Yes. So she said area under the curve. We know that, this is kind of what we talked about in recitation last time. Distance traveled is velocity times time. But if the velocity is changing, you have to think about it piece by piece. So what you did was you said, okay, this piece that I'm highlighting in orange, this piece is 20 meters per second times 2 seconds equals 40 meters. And then this piece that I'm highlighting in blue, I'll get out of the way of the camera in just a minute. This is, let's see, 2 more seconds times 10 meters per second. So 10 meters per second times 2 seconds equals 20 meters. And then you said, okay, well, you said the total distance would be 40 meters plus 20 meters equals 60 meters. That's what everybody did. So keep that in mind. So we did distance equals velocity times time, and multiply geometrically means multiply the time axis times the velocity axis. Gonna check the time here real quick. Okay, we're doing good. Oop, what have I done? That's the button I want. So now what I want to do is I want to gradually make this more abstract. So I'm going to erase this graph. And I'm going to I'm going to leave that graph here. And I'm going to make another graph. So now, what if I were to give you this one? What if the velocity versus time graph looks like this? And yes, as Yulin says, you can make sure you're doing this the right way because you know the units of velocity are meters per second, the units of time are seconds. The seconds cancel and give you meters, which is distance. So we can write that up here. And the units check out. So Ian says it's going backwards for when the function is below the x-axis, yes. So here, we're going backwards. Here, we're going forwards. But how could I calculate the distance traveled? Denara says find the area under the curve with the midpoint rule. Yes. What were you going to say?
This is good.
Yeah, so still do the area under the curve. You can't see the top bit of the board. There's nothing super important up there. We'll make that go away though. Blank. There you are. So yeah, you add the areas up. Because if all we know is distance traveled equals velocity times time, I could imagine creating a bunch of little areas here. Right? Turn this into a lot of little velocity times time boxes. And doing, write this over here, I could say distance traveled equals the red boxes minus the blue boxes. Yes. Just so I know, there's the edge of my blackboard. I just made a piece of chalk mark over here that's as far as you can see. And as Miles says, this is calculus. Porpoise, I will come back to that in just a minute. We're getting to that at the end of class. Yeah, we'll have time. So, Dun says, ew, Riemann sums. Yes, this is a Riemann sum for those who've studied this in calculus. And at this point, I am stuck. I cannot do anything more unless I know the mathematical form of this green curve. Porpoise says if we're subtracting blue, then it just looks like it means displacement. Give me 20 minutes and I will answer the thing you are asking. Let me just read all of this chat. All right, but now make it infinite rectangles. I'm going to run out of chalk if I do that. If you want to make it, though, if you want to make it 10 million rectangles, take Physics 307, which is computational physics, in the fall. It's a fun class. I've taught it for years. So what I want to do now is I'm gonna do 2 more blackboards worth of notes. We're going to make all this go away, and I want to return to our abstract description of position, velocity, and acceleration. So, everybody got this? So I'm going to make this go away and kind of summarize what we have learned. And again, folks, I really appreciate any feedback you have to offer me about the way I'm using the Blackboard here. Again, I usually teach this class with slides, but we have the luxury of doing real Blackboard stuff here. Because we're not in a giant auditorium anymore. I'm just in a little studio with Blackboard. So what we have learned is we have our three ideas, position and velocity, which we've just talked about. And we know that velocity is the rate of change of position, which, if you speak calculus, is also called a derivative. But if you go the other way, then position is the area under the curve of velocity. And that is called an integral. Now, we can go one further. As we discussed before, acceleration is the derivative of velocity. It's one more derivative, right? It's the rate of change of velocity, which is also a derivative. Going the other way, well, how do I get from acceleration to velocity? What do I do? What goes down here? You integrate, yeah, you do the same thing, right? Which is another integral. So this tells me now how to understand free fall. So this was our task, right? Was to understand Galileo's observation from the Leaning Tower of Pisa that he's reputed to have made. We know the acceleration is a constant. And if I want to go from acceleration to position, what I need to do is to take the area under the curve twice. So I have 15 minutes left, and that's what I'm going to do in the rest of class, 13 minutes. So I'm going to go a little bit faster than I often do, but we can review this again next Tuesday. We'll have time, but just barely. So I'm going to erase the board, and we will draw some curves. And this time we're going to put variables on things. How far over here can I go? So,
I took a picture.
Send it to me. Yeah.
let's see, how do I want to do this? I don't know. So, time, acceleration, and the acceleration versus time is constant. We'll just label this A. Remember, A is constant. And this amount of time for which we I'll label as T. Twitch people, we are talking about physics here, so like if you want to meme about physics, fine, but please keep Twitch chat clear, because I only turn around once in a while, right? And if all I see is a page full of memes, I miss people's questions just because I'm not always looking at Twitch chat. Adam, this is different than Astro 101, because Astro 101 I was always facing my computers. Here I'm often facing the board, so if there's been a page of memes, people's questions might scroll past me. So I'll label this time as T. Yeah, Adam, that would be fine. Krithartha says, or you can just answer them, Adam. You know all this stuff. Krithartha says this is uniformly increasing speed. Yeah. So let's draw that graph. So the velocity graph versus time, it increases at a constant rate. Yeah, physics mode activated, Nator. I will do that. That's going to be our class meme. All right, Twitch chat. If I say physics mode activated, that means we want to make sure everyone has an opportunity to learn. We will have lots of opportunities for memes here, but when we are in physics mode, please, physics mode. Siddiqui, can we explain the top chart? This means that object moves with an acceleration a for a time t. And we're trying to figure out the consequences of that motion. In symbols, we would write a equals constant. It's just a number. We don't know what the number is yet, but it doesn't change. I need a light up sign that says physics mode. I can make a button in Open Broadcaster Studio that does that. So this graph, people were saying it is just a constantly increasing function. So this just increases like so. This is again t. But what is its maximum value? What goes there? How high does the pink line get? Remember, the velocity is the area under the acceleration curve. Yes, Sean O'Toole. Remember, I'm supposed to look at the area under the curve. So this value, I'm going to draw a big arrow. The velocity as a function of time is a times t. This is a big deal. We figured something out here. Right? So we did here the area under the curve. But now if I want to find the distance traveled, if I want to know position, how do I go from knowledge of velocity versus time to knowledge of position versus time? Dunes, I am coming right back to that. Yeah, exactly, Krithartha. Area under the triangle, right? So I still have my orange area under the curve chalk in my hand. So what is the area under this curve? One half. Okay. So we got to do this a little bit cleverly. So I'm going to erase this. So what I know, I figured out that the acceleration is constant. This means that the velocity as a function of time is AT. But now I have to do one more area under the curve. So let's do that. This line, you just told me was AT. So this shape is a triangle. Yeah, Krutartha. The formula for the area of a triangle is 1/2 base times height. Let's write that down. The area is, we're going to go to yellow chalk here. Area is 1/2 times the base times the height, which is 1/2 times t times AT, which tells me that the position as a function of time is 1/2 AT squared. What quotes, let me see what Zoom has said here. Area under the curve of acceleration is velocity. Area under the curve of velocity is position. Exactly. I've got 4 minutes left. I want to do one more thing in my 4 minutes, and then we will review this next time. What if, so here I assumed that the velocity started from 0, right? But I don't want to do that. What if instead of, say again? Oh, you're talking to each other?
Yeah.
What if the velocity, instead of starting from 0, started from some other value? And that was the question that we had. Sarah, yes, I will draw the position versus time graph at the end. I want to go quickly just so I can let you all out in time here. So, if the velocity graph instead looks like this, where I have started at some value v0, which is my initial velocity, and I have increased over time, well, we already figured out that this increase was acceleration times time. So this maximum value here is going to be v0 plus AT. Or let me label it this way, this amount is A times T. So how do I figure out, yes, Catherine, you answered the question I was about to answer. I could do the math for the area of a trapezoid, or I could take the area of the triangle plus the area of the rectangle. World 2002 says the shaded area of the triangle, yes, it's the total distance. So all the stuff you all are saying in Twitch chat is all true. Sorry, I'm going quickly just to get you all out in time. So this shape, remember I've got to find the area under this to find the distance traveled. So I can take the triangle. So this has an area of 1/2 base times height. I hear you all in the back saying exactly that, which is 1/2 t times AT. Add it to this area,
Which is base times height.
which is just base times height, yeah, because it's a big box, right? So this
Is T times AT.
is V0 times t,
Mhm.
because this height is V0,
Oh, yeah.
right? So this is base times height, which is,
V naught, it's like the initial velocity.
yes, v0 here is the starting speed of the object. So then if I add them, this gives me a total distance traveled x is a function of time. I'll write delta x for distance traveled is, you'll color code this, v naught t plus 1/2 at squared. So, I am out of time. I know I have gone faster than I would have liked. I'm just going to step out of the frame here so you all can see. I've gone faster than I hoped to go. We will come back and take this a little bit more slowly next Tuesday and review this idea. But what we've gotten here, of course, Akla, see you later. What we've gotten here is a formula that tells you if an object is moving with constant acceleration, how far does it travel? You'll be applying this idea in your recitation tomorrow. This is the big idea I wanted to get to. We talked about recitation a bunch ahead of time. But we will slow down and look at this idea again next Tuesday. We have lots of time. We're going to kind of go a little bit fast in the beginning of class so we can slow way down later. Thank you all. I see all of your thank yous and stuff like that. Thank you, Sean O'Toole. Said Ferret Boy, I don't know what that Twitch meme is. Yo mods, when will the recording be available? I am going to right now click stop recording on